Hello, we're going to be doing Unit 2 test corrections for the LCM, GCM, and prime factorization test that we just took. Follow along, and I will be solving these problems as I would, as I was thinking about them. Question number 1. Gabriella was making goodie bags for her party. She made one for each person coming to the party, not including herself. She had 12 pencils, 42 bracelets, and 54 pieces of chocolate. All of the bags have the same amount of each candy. Probably it should have said same amount of each item, and nothing was left over. How many bags did she make? So this sounds like it's going to be a GCF problem because we're putting things into goodie bags. We're making groups. So the first thing I have to do is to prime factor each of our numbers. And I'm going to start with prime numbers when I can, when I'm thinking about it. And the exponential notation for 12 would be 2 squared times 3. And then for 54, we have, I'm going to do 9 and 6. 2 and 3. So again, each of these are getting down to prime factored form. So we can only have prime numbers down here, nothing else. Okay, then I'm going to come over here and figure out what they have in common, which is how we do GCF, the factors they have in common. And I'm going to bring each of my exponential forms with me. And now I have to figure out what they have in common. So they have, according to this, they have 1, 2. They all have 1, 2. They all have 1, 3. Not any more, not any less. And then they only have a 7 for 42. The rest of them don't have a 7, so that's not a common factor. So we don't need that. All we need is 2 times 3. Get that going. Okay, so now I've got my 2 times 3, so I have to multiply those factors together, and I find out that the GCF is 6. So our final answer seems to be that we'll have 6 goodie bags. But I'm going to read the question again to make sure. She has 6, 12. Okay, how many bags did she make? So she made 6 goodie bags. Number 2, hot dogs come in packs of 8. Buns come in packs of 12. How many packs of hot dog and bags of buns would you have to buy to have an equal number of hot dogs and buns? Real life problem, you know? It's very frustrating. Okay, so since we're not looking for making these into groups, we're trying to find out how many packages we'll have to buy. That's kind of increasing our values. So we're going up, which means we're going to be finding the LCM of 8 and 12. So again, we're going to factor them. So our prime, the exponential form for each of these is 2 cubed and 2 squared times 3. And when we're finding the LCM, we are looking for the highest power for each base. Each base has to be represented. So we have 2's as a base and 3's as a base. So I'm going to use 2 to the 3rd power, which is the highest value between 2 cubed and 2 squared. And I'm going to use 3 because there's no other 3, so I have to use it. So 2 cubed is 2 times 2 times 2, which is 8, times 3. So the final answer is 24 hot dogs and 24 buns that we'll have to buy. So that's the number, so that is the LCM, but the question says how many packs? So hopefully you didn't get tricked by that. If they come in packs of 8 and they come in packs of 12, we now have to take the LCM and divide it by each of those. So it's going to be 24 divided by 8 equals 3 packs of hot dogs, and 24 divided by 12 equals 2 packs of buns. Okay, so again, making sure that after you solve a problem, you go back and check to make sure you've answered the question. Okay, so how many packs? So the final answer It's 3 packs of hot dogs and 2 packs of buns. Number 3. Kira baked 30 oatmeal cookies and 48 chocolate chip cookies to package in plastic containers for her friends at school. She wants to divide the cookies into identical containers so that each container has the same number of each kind of cookie. If she wants each container to have the greatest number of cookies possible, how many plastic containers does she need? So we're putting these into groups. We're making smaller sections. So we're going to have to find the GCF. And again, I need to factor my values. And again, we're trying to get down to prime numbers. We can't stop until everything's prime. So this is 2 to the 4th power times 3. So our GCF, we're writing our values again in exponential form when possible. And we want to find out what they have in common. They both have a 2 in common, and they both have a 3 in common. They don't have any 5s, and they don't have multiple 2s, just the 1 2. So again, 2 times 3 is 6. So it looks like we're going to be able to package 6 containers of cookies. And let's see if it's asking us what kind of each goes in there. It's not. So if if we wanted to, we could have figured out how many oatmeal and how many chocolate chip would be there by dividing it. But the question didn't ask us to do that, just to find out how many containers that we can buy or we can make. All right, number 4. Boxes that are 15 inches tall are being stacked next to boxes that are 9 inches tall. What is the shortest height at which the 2 stacks will be the same height? Well, obviously, we're looking for the LCM because we're looking, the action is repeating. It's getting larger and taller. It's not going to get smaller. We're not going to have a block. We can't have a height of smaller than these 2 values. So we're finding the LCM. So we're going to find the value for 9 and 15. So again, exponential form when possible. And with LCM, you're finding the highest value for each base. And when we have 3's, the highest value is 3 squared. And there's no repetitive 5, so we have to use the 1 5 that's given to us. 3 squared is 9. 9 times 5 is 45. So this is saying that our blocks, the shortest height that they're both going to be equal, will be at 45 inches tall. So just so you know, we'll need 5 blocks of this one to equal 45, and we'll need 3 of the 15-inch height ones so that they equal the same height, when they're drawn. So if you visualize a block, this is 15 inches tall and this is 9 inches tall. Well, we'll need to, how many will it stack is basically what it's saying. So we'll need 5 of those and only 3 of those, just as a visual. All right, find the GCF of 48 and 90. So just computation. Besides, so you don't have to worry about reading a word problem here. Just making sure your math is right. So this one is 2 to the 4th power times 3. I'm going to 2 times 45. And again, making sure you put your values in order from small to large. Alright, to find the GCF, again, we're finding what they have in common. Not the largest power, but what they have in common. And these are coming from down here. So we have a 2 in common, and they have a 3 in common. So again, we have a GCF of 6 for this. The LCM of 12 and 18, so again we have to factor. probably getting to the point where you can memorize some of these, can't you? Still have to show your work though. So LCM of 2 squared times 3 and 2 times 3 squared. So again, LCM, you're looking for the largest power of each base. So we have our bases of 2 and 3. So of our 2's, the 2 squared is the largest, and of our 3's, the 3 squared is our largest. So 2 squared is 4, 3 squared is 9. So the LCM of 12 and 18 is 36 because they both can go into 36. It is a multiple. Alright, number 7, list the 4 factors of 60, not including 60. So I just basically wanted you to know that, figure out what other things could equal 60. So I'm going to do a T-chart for this. So I'm going to do 1 and 60. Again, that's not going to count for you, but I wanted you to know it is a factor. 2 and 30. 3 times 20 equals 60. 4 times 15 equals 60. 5 times 12 equals 60. 6 times 10 equals 60. 7 does not go in at 8. 9 and 10 and back to 10, so I know I'm done. So as long as you had 4 of these numbers, any of these 4 except for 60 would have worked for factors of 60. So this is the factors. Now for multiples, I'm going to go over here to make room. So for our multiples, we're looking for values that are 60 that 60 can go into. So I'm going to say 60 times 2. So a multiple would be 120. A multiple could be 180. So I'm taking my value and multiplying by any number. 60 times 4 is 240. And I could just do 60 times 10 and do 600. So each of those are multiples of 60. 60 can go into those. These are factors. These go into 60. Prime numbers under 20. So prime numbers are the numbers that only have factors of 1 and itself, and that's it. So 1 is not a prime number. So I'm going to put this here, not prime. 2 is 3, 5, 7, 8, 9, 10, 11 is 13, 17, and 19. So these are your prime numbers under 20. Alright, for this one we're talking about describing in paragraph form how you would use GCF to simplify a fractional answer. And for the sake of time, because I've only got 2 minutes left in my recording, you would factor 120 and 180. So you would talk about how to factor the prime factorization of 120 and 180. And then whatever that factored answer, whatever the GCF was, you're going to divide that into each of those numbers. So it'll be 180 divided by the GCF and and 120 divided by the GCF. And that's really going to help us come time when we get into fractions in a few weeks, or really a few days. So this answer will put us into simplest form. Sorry to rush that one. And then our last one is explain the difference between a prime and a composite number, giving an example of each. So prime, again, are the numbers that are only divisible by 1 and itself. And composites are divisible by multiple numbers, divisible evenly by multiple numbers. Oops, sorry. Let me erase that. Divisible by multiple factors. And both of these are greater than 1. They're prime number. I mean, they are positive numbers, positive integers. Okay. An example of prime would be 3, and an example of composite would be 4. And that's it for the test corrections. I've got 15 seconds remaining without having to go into a second video. So hopefully that helped, and if not, come see me during focus time and we can talk through the problems.